Now I'd like to introduce Claude Cellier from Merging Technologies, who is going to be talking to us about the real-world large-scale applications of Ravenna networking in recording.
Guys, you're doing a great job, and thank you for being with us up to now. I'm glad I'm the last speaker of the day, and I'll do my best to take it very easy and relaxed, and with as little diagrams as possible. There may be one or two, I'm afraid, but there will be more pictures in my presentation. And nuts and bolts will be, again, limited to very helicopter view presentation of some installations we did over the past 2 years. And first of all, I wanted to introduce my presentation with a bit of history, which worked fine with Roland. I don't think he's with us any longer. He's left, unfortunately, but he went all back 3,000 years ago. I will be much more modest and keep within a 30-year range, rather. And I want to go back to the great old times of analog, where life was really simple. There was almost no delay, no latencies. I mean, as close as you can get from the speed of light limitations on a copper wire. Distribution was ultra simple on qualifying network infrastructure. What do I mean by that? Is that in analog times, you could bring a source to sinks, as we call them these days in network literature, doing just a wire. I could do that myself with a number of soldering irons or just banana plugs, and here you are. You have a source being sent to two sinks in basically no time and with no major complexity. I remember doing those things a number of years when I had to bring a source to more than one low-cost speaker when I was a student. Then came the digital times. Great fun. A lot of additional complexity. You had to add a number of additional boxes in between your source and your sinks. And one thing which was basically prohibited is what you see on this picture. You wouldn't do that like that on an AES or a BADI-Link or a TDIF or SPDIF or whatever. This was next to prohibited. So no networking, gone. Then we decided to reinvent the wheel. So 30 years later, we are there, and we can do on a relatively simple manner the same thing we did 30 years ago and longer than that in analog, which is to bring a source to multiple sinks with a unit in between, which is called an Ethernet switch or IP switch. But in the meantime, to do that requires some millions of transistors around and several thousand lines of code. Well-written code, of course. So, short story. Replacing cost-intensive proprietary audio and video routing infrastructure, so-called routers, and now replacing those with standardized network infrastructure is what we're dealing with. One of the main target, at least initially, of the products we were developing in Ravenna is to be able to respond to some broadcast requirements, and those are usually pretty stringent and severe, so we felt that's a good start to base our requirements on. They want to deploy on existing network infrastructure. They don't want to have to replace all their investments, of course. The network topology can be of any structure, and it should, in an ideal world, be able to coexist with existing traffic. So it has to be able to share traffic with other devices. It has to be scalable. Ideally, the technology should be able to supporting several hundred streams concurrently, and the stream can be anything from 1 to 8 channels or even 64 channels. The latency should be low. That has already been mentioned a few times here. It should be able to support any sample rates and data formats, PCM, and as you'll see, we'll also use that technology to stream DSD more recently. All the system must have failover capacity and redundant and high availability structure. Now, native PC support is a must because more and more gear runs on off-the-shelf PCs or tablets, if not just iPhones. One, routing capabilities, so broadcasting typically cannot be satisfied with just a local island solution. They want more than that. Non-proprietary solution, Andreas has already mentioned that, and it should be based on standard. Why IP-based networking? This has already been addressed by other presenters today. One of the important aspects of IP is the fact that you can route your signals through network with having as little impact on user skills doing that. And there is a convergence here of IT technology being developed for PCs or Macs. I mean, when I mention PC, it can be any computer system where the more it goes, the less we see a need for dedicated I/O technology. For us, the period of time where we needed dedicated audio cards in the computer are all gone, since most of these computers, even laptops or notebooks, do incorporate a gigabit Ethernet connector. It makes all the more sense to use those straight for having audio being streamed in and out of these computers. IP-based services is also a good future-proof bet, since we in the audio business are only a very tiny, small portion of the entire IP technology development. Okay. Beyond broadcast, for us, we had also, of course, the need of being able to open this to other applications, and particularly live applications, install market, live market, recording studios, backpack recording style, or large recording studios altogether, which brings us to the slide which I will go quite rapidly through, the technological key features, because Andreas has already addressed some of these, with just 2 or 3 sentences. First, on quality of service. Our experience so far in the field has shown that quality of service is rarely, if ever, an issue. We haven't had so far reports from the field telling us that quality of service, having packets lost or not arriving because of traffic congestion or other similar problems were never a case. The other element that is also of important is that we have seen that this technology works similarly well with very small network, which basically are point-to-point operations in essence, with just a mic preamplifier box in the stage and a computer to record the streams coming from the stage, up to much larger infrastructure. So it scales very well on all these topologies. I think that has already been shown today, so I'll skip that rapidly. In terms of what we see on the side of our users is that they love the fact that it's an open and public standard, and even more so today as AES-67 has been ratified last year, and the first AES-67 Plugfest has concluded successfully just a few weeks ago. So this is a safe bet to go with, particularly as it's open and it's based on public standards. The source code access also is something that is of interest to our users, because it allows all the ecosystem of Ravenna partners to move much faster with shared resources. It's that much more comfortable when you are not alone, having to develop all your code by yourself. By today, we have also various platform implementation, which is extremely useful: Windows, Mac, and Linux. And there's an open community of adopters, Plugfest, and social networking going around AES-67. It's also easily expandable to additional data formats, which is not the case with other systems. One short example I will take here is over time we decided that it would be a good idea to transport not only PCM, but also DSD over IP. And basically the only thing we had to do is to define a new payload type, and we defined 3 of them, one for DSD64, one for DSD128, and for now we content stopping at DSD256, which is already quite an achievement. And a full description in the SDP, and that's it. And we, on a 1 gigabit Ethernet, can safely transport more than 48 channels of DSD256 at 11.2 megahertz. Just to give you a relationship to what that is in terms of standard PCM channel, that would be well over 400 something PCM channels at 48 kilohertz. This is something nobody has probably had the time to show you. Normally Andreas does this job for me, but I didn't see it in his presentation. It's a quick overview of the various systems and different protocols that are existing on the market as of today, showing on a OSE layer the 7-layer structure where those different protocols are working and what they use in terms of protocols at each level of the OSI model. And the network layer being layer 3 from the bottom, you can see that there are actually 2 protocols that use that layer 3. Ravenna, AES-67, and Dante, and LiveWire, of course, too. A quick word on to complement what Andreas was addressing this morning around what are the main differences finally between Ravenna and AES-67, if there are any. It's tiny. I mean, it mostly fits on this page which you have in front of you, and that's not much. You have to look at those definitions as two different views of almost the very same application. In one sense, Ravenna is an open operational solution, while AES-67 defines the common interoperability standard. So it's not a big difference, but in the terminology, that's really what the difference is between those things. And just that Ravenna has an additional discovery mechanism defined, whereas AES-67, as we've seen earlier today, doesn't mandate, as of today yet, a discovery service, and maybe doesn't want to. So, what did merging do in terms of developments since it went on board doing networked stuff? We presented in 2012 a number of products. That was really the introduction year for Ravenna-based systems. Out of them I'm listing those quickly here. A virtual sound card for PC, ASIO-based 64-channel. Together with that, we launched a PCI sound card, PCI Express, allowing 384 channels of I/O out of a PC on a single card, and it provided also acceleration for our own mix engine, which is a real-time operating system coexisting with Windows, next to Windows, sort of speaking, that guarantees the deterministic behavior of a Windows-based PC for audio applications. We also introduced our first I/O converter and audio interface called Horus, which is a large system allowing something over 200 channels of routing in and out with MIG preamps, MADI, AES, etc., being built to connect to a Ravenna network. Then, of course, application-wise, we made sure that both PRMX and Ovation, which are our two main software applications, were ready to talk to a network as well at the same time. And by that same token, we were also one of the first DAW companies supporting Dante. That was even before 2012, I remember. So then this year we introduced some further products like the Core Audio driver for Mac, which allows AES-67 and Ravenna to be being driven by and talk on network on any Mac system, starting with Mac OS 10.7, and a new smaller device called Happy, which is a scaled-down converter and audio interface, which is, by the way, in the lobby as well, for those who want to see it. I've brought a few examples because that's one of the focus of this presentation this afternoon, of real examples we did over the past 1 or 2 years, or that our other Ravenna members did successfully deploy. One of the recent things, and I think Andreas also mentioned this, was the use of 240 Lavo commentary units at the FIFA World Cup World Cup in Brazil with an impressive set of gear showing that this technology is now no longer at the stage of laboratory, but can be used on highly demanding, where reliability is probably criteria number one events. And at the same time, we were having some of our gear used for the final concert, also in another live application at the World Cup concert. You probably see on the picture some well-known faces. And this was recorded onto an ovation system and a pyramid system. It was quite a short delay to have that all work between the time the engineer who was called in to do that job flew in from New York with a delayed flight in Rio de Janeiro to find out that the MADI links, which were supposed to be working, didn't work, and finding no replacement cables of good quality to make it work, had to resort on finally using purely Ravenna to have it all run. So, in a sense, this was quite a surprise for everyone to see that the so-called robust MADI link wasn't there, while the newer kid on the block was actually delivering the backup solution and made it a success. Again, Lavo did a great deployment of Ravenna systems at the Asian Games, this time with about 110 Lavo commentary units and 10 Lavo consoles. And we love to see those big live events seemingly adopting networked technology at an extremely fast pace, which is surprising. Now, an example closer to us in France, Paris, Canal+, not to name them. They had a request for their new live chains to integrate a number of workstations that would be sharing a number of I/O devices. And you see here a typical example of the sort of things that we can do today with networked technology that wouldn't have been possible to do in the same way with standard point-to-point technology. So we have a number of ovation applications sharing the I/Os, the line-ins, the line-outs, the mic preamps, whatever, embedded in two Horaces. And there are actually a total of 5 control rooms, all sharing actually the aggregated I/O capability of 2 Horace devices here, which allows for a significant cost reduction over standard ways of doing a cabling and deploying equipment. Another typical example that we are seeing more and more happening is museum installations. Museums are a strange animal. They do tend to want to be in the 21st century showing old stuff, but with latest state-of-the-art technology. And what we see here is a typical example of one central system to deploy music, sound beds, whatever, and even video shows in various rooms. And it becomes very easy to connect all those, provided you have a simple Cat5, Cat6 cabling going from one floor to the other. By the way, we did those things in Ravenna. We did those things also with Dante. so that things are clear. We are not uniquely deploying Ravenna-based networked systems. Now, something that happened to us, not against our will, of course not, but more rapidly than anticipated, is that many prestige places in the world, like the Los Angeles Philharmonic, decided also to deploy network technology together with our PRMix software to basically be in a position to record at any time the events that were taking place in their places. And one common thing that happens in those nice symphonic halls is that you have a set of microphones that are hanging basically from the walls, while you have another set of microphones which are brought in from the stage. And in both cases, it simplifies enormously the effort of cabling all that together into a single cable that then gets connected to a recording device and possibly a backup recording device. And you see here a typical example of the roof mix being joined in an Ethernet switch by a number of stage microphones, and all those being then sent to a recording device. This is only one example. We have another at the Chicago Symphonic Orchestra, which, by the way, you see the picture of it. You see just the height of this room is a magnificent height. So having an easy-to-deploy Cat6 cable from all up there, which might take anything from 60 to 100 meters down, without having to resort to complex multi-core cables, is a great benefit for these halls. One thing further that has to be said, in case even you have to go beyond 100 meters, there are extremely affordable systems to convert Cat6 to optical and back at whatever required, so that's not a big deal. Meanwhile, what happened is throughout the USA, we covered pretty much all the main, at least some of the most prestigious places, like the New York Philharmonic, the Boston Symphony, the Detroit Symphony, the Dallas Symphony recently, San Francisco Opera, the Los Angeles Philharmonic, the Seattle Symphony. They are all places which run now Ravenna and AES-67, therefore. What we see is, and it's too bad for Roland, who just left, but he was looking for some numbers, so I said, let's bring in some numbers for him for updating his analysis reports next year. So what we see is really an exponential adoption rate by now, year to date, 2014. We have about 2,000 Ravenna nodes in daily operation, and that's just those that have been developed since 2012, so in just barely over 2 years. Out of these, there are 750 of these nodes for the networked converters, be they Horus or more recently Happy converters, and out of these, there are 550 for mass core PC nodes, so the ultra-deterministic, low-latency mix engine running on PCs. And the remainder being either native ASIO, Windows, or Core Audio Mac nodes. And in conclusion of my presentation, which I specifically wanted to make on time because we have of course, a question and answer question, but then the drinks party. I didn't want to extend on that one. What are the next steps? Control, control, and control. This is going to be the big thing that remains for this industry to work on if we ever want to achieve some form of interoperability in there. And that isn't an easy task. I bet it's going to take many, many years for us to get to some form of interoperability in that thing. Thank you very much, and I'm done.
Thank you, Claude.